This is MD Tanvir Chowdhury and I will discuss the algorithm of insertion sort. Before knowing what is insertion sort, we need to know what is sorting. In simple way, we can say that the arrangement of data in a preferred order is called sorting in the data structure. For example, let ARR be a list of n elements ARR1, ARR2 in that way up to ARRn in the memory. Sorting the list ARR refers to the operation of rearranging the contents of ARR so that they are increasing in order numerically or alphabetically or by the value in the key. Insertion sort is a simple sorting algorithm that works similar to the way you sort playing cards in your hands. For example, let's take an array with n elements ARR1, ARR2 in that way up to ARRn in memory. The insertion sort algorithm scans ARR from ARR1 to ARRn, inserting each element ARR key into its position in the previously sorted subarray, that is ARR1, ARR2 in that way up to ARRk-1. Let's use an example to better understand the insertion sort algorithm. Let's take an array that is 81, 17, 25, 11, 95, 20 and 58. This curve arrow will indicate the proper position for the element. This green circle will indicate the sorted subarray. This red circle will indicate the unsorted subarray, and that gray circle will indicate the element to be checked. Let's try to understand the insertion sort algorithm step by step. Step 1. At first, we will compare 81 with all the elements of its left. Here 81 has no elements in its left, so the array after step 1 is 81, 17, 25, 11, 95, 20 and 58. In step 2, now we'll compare 17 with all the elements of its left. Here 17 is smaller than 81, so the array after step 2 is 17, 81, 25, 11, 95, 20 and 58. In step 3, now we'll compare 25 with all the elements of its left. Here 25 is smaller than 81 and greater than 17. So the array after step 3 is 17, 25, 81, 11, 95, 20 and 58. In step 4, now we'll compare 11 with elements of its left. Here 11 is smaller than all the elements of its left, so the array after step 4 is 11, 17, 25, 81, 95, 20 and 58. Step 5. We will compare 95 with all the elements of its left in step 5. Here 95 is greater than all the elements of its left, so the array after step 5 is 11, 17, 25, 81, 95, 20 and 58. Step 6. Now we will compare 20 with all the elements of its left. Here 20 is greater than 11 and 17 and smaller than 25, 81 and 95. So the array after step 6 is 11, 17, 20, 25, 81, 95 and 58. Now in the final step we will compare 58 with the elements of its left. Here 58 is greater than 11, 17, 20 and 25 and smaller than 81 and 95. So the array after final step is 11, 17, 20, 25, 58, 81 and 95, and that's our final array. That's all from me. Now my project partner Nihal Hasan will discuss in detail about the time complexity of insertion sort. Thank you.
Assalamualaikum sir, I am Nihal Hasan. My ID is 20217406442. Now I am going to describe the time complexity for insertion sort. Time complexity. Possible time complexities for insertion sorts at the worst case complexity, average case complexity, and the best case complexity. For best case complexity, when the array is already sorted, the outer loops run for n number of times, whereas the inner loops does not run at all. There are only n number of comparisons, so the total number of comparisons for best case in insertion sort n-1 denotes order of n. Next we move to the average case complexity. When the elements of an array are in neither ascending nor descending order, so this time the total number of comparison of average case is order of n square plus order of n square, which is equal to order of n square. Next we move to the last part, worst case complexity. when the array is sorted in ascending order. To sort it in descending order, each element has to be compared with each of the other elements. So, for every nth element, n minus 1 number of comparisons are made. So, the total number of comparisons for worst case is n minus 1 plus n minus 2 plus dot 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 plus 3 plus 2 plus 1, which denotes order of n squared. Lastly, the space complexity, and the space complexity is order of 1. Thank you, sir. Thank you so much.